Hello everyone, I will continue that Venturimeter that derivation. Already we have derived this Venturimeter. Venturimeter, it is having a convergent portion, divergent portion and a throat. I have taken two sections. One is at a pipe at inlet, that is one, where the diameter is d1, cross-sectional area is a1 and velocity is v1. Throat, it is again the diameter is d2, a2 and v2. Where the pipe diameter is always it is greater than the throat diameter here. So therefore that the cross-sectional area of the pipe is always greater than the cross-sectional area of the throat here. So next I have derived the theoretical discharge equation by using the Bernoulli's equation, that is theoretical discharge is equal to a1 into a2 under square root of 2gh divided by under square root of a1 square minus a2 square here. Here A1 is greater than that A2 here. That cross-sectional area of the pipe is greater than the cross-sectional area of the throat here. So how we are using to solve the numericals here now? So A1 and A2 we can find it very easily because these are the geometrical parameters. If we know the diameters d1 and d2 at pipe and at a throat, d1 and d2 is at throat, d1 is at pipe. If we know, if the pipe is a circular shape is there, then we can find out that means what the a1 is equal to pi by 4 into d1 square and also a2 is equal to pi by 4 into d2 square. If it is a circular that cross section is there, we can find it very easily. 2 is there, okay, no problem at all. G is in SI unit, it is a 9.81 meter per second square is there. Here the problem is H. H is what? H is what? What it will be this one? And how to find out? H is the, it is not a height, it is the differential pressure head here, but it is in terms of meter and centimeter only. That means what the unit is distance, but it is in terms of that liquid or fluid columns. For example, if that means what in the pipe, if the water is flowing, this H will be called as meter of water because it is a pressure head. It is not a distance here. So how to find out this one? Usually to find this H here, so in case of the Venturimeter here we are to find out that the pressure differential pressure head, we are connecting a manometer. How we are connecting that manometer here now? Just I will show that diagram here. So in this, if this is the that means what one Venturimeter here, just one Venturimeter. If I take a U-tube that manometer here, one limb of the manometer, it will be connected to the pipe where that section 1 is there. I will connect that means what the pipe, that means what where the section 1 is taken, it will be taken at the inlet pipe here, very nearer to that throat. Very nearer to the throat, almost it is of 0.5 d diameter, 0.5 times a d. That section has to be taken where that the left limb of the manometer is connected. And usually we are taking that section 2. Usually means definitely we are taking that section 2 at the throat only, and the other limb, that is the right limb of the manometer, it is connected to that means what where we are taken that section 2, it is at throat. Yeah. It is a U-tube manometer. This is a U-tube manometer here. In the manometer means, as we know, manometric fluid will be there. So manometric fluid, for example, in the pipe, if the water is flowing, manometric fluid usually it will be taken as a mercury. In the mercury, that means what mercury is taken as a manometric fluid. So this is the that means what the manometric fluid Hg or It is called as the manometric fluid. This is the manometric fluid. So when this fluid is flowing in the venturimeter here, what happens? These levels in the manometers at left limb and right limb will take place here. So difference in this level, if we that means designated as X value, means this difference in these two level. This is the level at the left limb. This is the level at the right limb. This is X is the that means what the manometric level difference. That is X. It is in centimeter. Sometimes it has to taken in terms of meter. Here X is there. Then if we know the levels of the mercury in the manometer, it is not a differential head H. It is not H. X is different, H is different. Here very important thing is X is not equal to H. Here H is the differential pressure head, X is the, that means what, the levels, difference, that levels of the manometric fluid in the that manometer here. Then how to find it? How to find that H value? By knowing the X value here. There are some 3 cases are there here. That 3 cases to find H value. Here we will study here. So in that, first we will study case 1. Case 1. What is this? The case 1 here. Case 1 is what? When the pipe is horizontal. The pipe is what here now? Pipe is horizontal. A pipe is horizontal means Z1 is equal to Z2. Then again, that means what the condition is in the case 1 is what? If the manometric fluid is heavier than the pipe fluid. Manometric fluid is heavier than the pipe fluid. Here, what is the meaning? What is the meaning here now? Meaning is what? The specific gravity or density of, that means what? The manometric fluid is greater than the specific gravity or a density of the pipe fluid here. If you are comparing specific gravity, take both for pipe fluid and manometric fluid specific gravity. If you are taking a density, both the side you have to take the density here for the comparison purpose here. So now that means what? How to, if we know the X value, X is known here. X is known. Then how to write a formula for the H here now? The formula for the H is, that is differential pressure head H is equal to X in the bracket. First we have to take specific gravity. If I am indicating this specific gravity as S, S is the indication of this. Specific gravity of the heavier fluid. Specific gravity of the heavier fluid divided by specific gravity of the light fluid. Light fluid means light fluid, or else it is called as the heavy fluid. Pipe fluid, that we can call it here. Heavier fluid is the manometric fluid. Then specific gravity of the heavier fluid divided by, that is a light fluid, minus 1 and bracket completes. So what we need to find, that means what this H value here now, we need when the pipe is horizontal, the manometric fluid is heavy, then that means what we have to take, that means what this equation, X is the difference in the manometric levels, it is in terms of centimeters here now, and The S is the specific gravity of the heavier fluid in the manometer, and S light is the specific gravity of that pipe fluid here now. So these are in specific gravity also we can take, or else we can take X in terms of density also. We can density of that heavy fluid here divided by the density of that sort of the light that fluid minus 1. In terms of density also we can take, in terms of specific gravity also we can take. As we know, specific gravity is not having any unit, density has that unit here now. The same in case 2. Just let me sort of, just I will make it into the case 2 here. So in case 2 here, in case 2, pipe is horizontal but in a reverse. That means manometric fluid is light here now. So manometric fluid is light, means pipe fluid is there, pipe fluid is heavy. Then how to write the equation? Just modification in that equation is H is equal to X in the bracket 1 minus we have to take specific gravity of the light fluid divided by specific gravity of the heavy fluid. Means what here now? Heavy fluid now it is in the pipe here now. This is in the pipe here now. The pipe fluid we have to take at the denominator. It's a heavier one. We have to take denominator here now. This is the equation when that manometric fluid is lighter than the pipe fluid here now. If you write in terms of density, 1 minus density of light divided by the density of this heavy here. So next in the case 3, we will come in the next video, just a short video, that case 3 is there, because this video will becomes very heavy. I will continue in the next video. Thank you.